All right, so now we're going to work on some problems. So it says write the general antiderivative. So that's the one with just plus c. So we have a constant times a exponential. So what we're going to get is that constant, 19.4, times, and remember, we're just going to have 1.07 to the x in the numerator, and on the denominator, the ln of 1.07. And then that's all plus c. Okay, and that's all it is. Again, memorizing the different antiderivative formulas is going to help you be able to do a lot of these problems really quick. All right, so this one we can do, in parts. We can take into the antiderivative of this plus then the antiderivative of this, or we can just work your way left to right as a polynomial and we can get it. Well, antiderivative of e to the x is just e to the x. I can write e. And then we have, again, another one with exponential, so it's going to fit the following rule for 2 to the x over ln of 2, and then plus c. Again, nothing difficult. We're just using the formulas that we were given. What about this one? Well, 10 to the x, well, that's going to give us 10 to the x over ln of 10. And then we have this one is 4 over x, so that's going to be plus 4 ln of x. And then here we have plus sine of x, so the derivative, that's a negative cosine of x. And then we have plus c, okay? All right, what about this one? Here we'll treat this as an exponential or we can treat it as the e to the kx. Either way, they both will work. And so if we do it with e to the kx or the other one, it's going to come out the same answer. So we have a 1.8 e to the 0.2p all divided by, and it's divided by 0.2 because it's actually going to be divided by, k, or it's going to be, e to the 0.2p over ln of e to the 0.2. Well, that comes down. Ln of e is 1, so we just have 0.2. So, these do the same thing. Now here we have then plus, well, it's going to be 6.2, and then it's going to be sine p plus c. Okay. So again, nothing difficult, just having to memorize some of those functions to be able to do these here. All right. All right, let's go. I think we have time. We can do a couple more. So write the general antiderivative with units of measure. All right, so we're going to take the integral from 0.04x squared minus 0.5x plus 1.4 over x, and that's all going to be dx. And so when we take that one, it's going to be 0.04x to the third over 3 minus 0.5x raised 1 squared over 2 plus 1.4 ln of x, and then it's going to be plus c. And it's dollars per 1,000 cubic feet per year, so it's going to be basically dollars per 1,000 feet cubed because we're going to drop that per year. Okay. Now, could we simplify this? Yeah, we could take 0.04 divided by 3, but that's going to start getting into the long decimals. That's going to be just 0.25. So, it's just a matter of do we really need to or not? You don't need to. This is kind of going to be a more exact form because the other one, 0.04 divided by 3, gives us 0.01333333. So this gives us a better answer, especially if we have to plug in some x value at the end. How about this one? Well, we're going to take the integral of 1.7 e to the 0.03 t. Okay, well, that's just going to be 1.7 e to the 0.03 t all over, and then depending on how you want to do it, if you just want to do the k, it's 0.03, and that's it. And it's million people per year, so it's just going to be million people, okay? So again, nothing difficult. We just have to do the memorizing of those antiderivatives and things should be good. Let's try another one. These we have to find the specific antiderivative. So that means we have to find c. So first we have to find the antiderivative, t squared plus 2t dt. And so that's going to be t to the third over 3 plus 2t to the second over 2 plus c. All right, well, now we've got our function. And so what we're going to do is we're going to set that equal to 700 and plug in 12. And so we're going to have 700 equals and 12 to the third over 3, and then plus, well, 2 over 2 is just 1. So I'm just going to say t squared. So that's just 12 squared plus c. And so if I do that, that's going to be 12 cubed, and then divided by 3 plus 144, and then subtract that. So it's going to be minus 20, or 720, rather. Minus 720, minus 720, and then it's a minus 20 equals c. And so our f of t is equal to t to the third over 3 plus t squared, and then minus 20. And so that would be our specific antiderivative. All right, what about the next one? Well, again, we're going to take the integral of 1 over z squared plus e to the z dz. Now, I would probably suggest that we would actually write that z to the negative 2 plus e to the z dz, because that's going to make it a little easier to do this, because now we can say, okay, well, we have basically our z, add 1, so it's going to be a negative 1 over, and then we have a negative 1 plus e to the z, and then plus our c, okay? And then we could rewrite that as, well, z to the negative 1 is going to go down, so it's going to be a negative 1 over z plus e to the z plus c. Now, we're given this. So now we have to say, okay, well, 1 is equal to 1 over 2, and it's a negative, plus e to the 2 plus c. So we're going to take and figure out that. So a negative 0.5 plus e squared equals that, and 1 minus that is going to be c equals a negative 5.889. And so our specific antiderivative f of z is, and we have a negative 1 over z plus e to the z minus 5.889. And that would be our final solution there. Okay. So again, learning those antiderivatives is really going to help you be able to solve these problems. All right, so let's stop there and we'll come back for more.